In today's video, we're going to look at DMX table screens in disguise. Hello and welcome to the Hive School. My name is Rich Porter and I'm making these videos to help you one-up your live video production workflows. As well as being able to drive video products, Disguise lets you control lighting fixtures via the lighting control protocols ArtNet and streaming ACN. This process is called pixel mapping and involves taking the brightness and colour data from a video file and converting it to the information that's needed to control lights. This can be an incredibly powerful way to bring the movement and energy of a video into your lighting rig. So how do we do this? There's three distinct parts to this process. First, we'll need to build a custom 3D object to represent each one of the lighting fixtures you want to map. Next, we'll have to go into Excel and create a table that will outline the DMX channels that correspond to each one of these lights. And finally, we'll pull this all together in Disguise and configure it for outputting lighting data. So let's start with step 1 and jump into 3D Studio Max. So I've created an array of polygon quads here. Each one of these is going to represent a single lighting fixture in an imaginary lighting rig. So let's just imagine we have 8 truss towers with 5 lights on each. In order to set these up for a DMX table screen, we need to generate a UV map. So I'm going to select my objects, go into polygon mode. They're all selected there. If they weren't, I could press Ctrl-A to select them all. Then in the modifier list, I'm going to just search for the Unwrap UVW modifier. We can open up the UV editor. And if I just arrange my screen so we can see both parts, each one of these polygons is currently taking up the entirety of UV space. So if we go through and select each of these, I could pull these out and try and park them in an order that sort of made sense to me. However, that would take a while for these, and imagine you had a lighting rig with hundreds of fixtures, it would just be a completely untenable workflow. So there's definitely an easier way to do this. I'm going to create a UV by generating a planar projection. So if we go down to the projection menu in the UV Unwrap modifier, click the planar mode. I think we need all our polygons selected for this, so I've just pressed Ctrl-A on the keyboard and I'm going to go best align. Now each one of the polygons is occupying a small section of UV space and none of them are overlapping. So that is a good start. We've got all this space in between each one of these polygons, and that's going to be areas where we're unable to map lighting data to that. So that's kind of unhelpful to us. I'm going to click the planar mode to turn that off, and now we should be free to modify these, so I can sort of select these individually. A lot of what I do in 3D Studio Max UV tools relies on the Poly Unwrapper plugin, and I can leave a link to that in the comments below. So I'm going to select all my polygons. I'm going to go to Arrange. I'm going to allow it to rescale, but we don't want any padding in between, so we're going to turn that down to 0 and allow it to pack them. If I select these now, you can see the top left is the top left polygon in our array, or top left light. As we go through, these have all retained their order, and that's really what we want to do there. We've got this section of UV space here which is not being mapped, which will be unhelpful to us, so I'm going to select all of them, go to Scale. Again, we're going to turn the padding down to 0 and turn off Keep Ratio to allow it to stretch this out to the full area of UV space. Open that out, and here we go. So that's pretty much what we need. I'm going to leave this open because I think this will be a useful visual aid as we start to talk about generating the table. Just so that it's ready for us when we move into Disguise, I'm going to export this model. So export. I'm pretty sure I left a folder on my desktop for my exports, and it needs to be an OBJ file. So just call this lighting array. This should all be fine. So we just export that, and we're going to move on into step 2, which is in Excel. In Excel, we're going to create a table that represents essentially the relationship between 4 pieces of data. Disguise doesn't read the first row in our table, so we can use that to remind us what these pieces of information are. So the first one is U. In our UV space, U represents the horizontal dimension. The second piece of data we're going to use is V, and that's the vertical space within UV space, so that's our top to bottom. And because each one of these polygons is, because our array of polygons is occupying the full size of UV space, if we set this to the same number of pixels as we have polygons, these will come to represent pixels. So this will be our first, second, third pixel, and so on. And that means we can reference them essentially by their coordinate. So D3 starts counting at 0. So this polygon will be considered 0, 0. So that's 0 from the top, 0 across. This one will be 1, 0. So 1 across, 0 down, and so on and so forth. So if I grab this one, this will be 0, 4. Hopefully that makes sense. And we're going to use these numbers to talk about which pixel or which lighting fixture we're talking about by its coordinate as we list them in this table. The third bit of data we need is the DMX universe. So in order to not confuse our two U's, I'm going to give that its full name, universe. And then the final one is channel. You can get this information from your lighting team, or if you've rigged and set up your lights, you may know this information already. To make life easy for us today, I'm just going to start on universe 1, channel 1. So we're going to start with our first light, or first pixel in our array. So as mentioned, that's going to be 0, 0. And then what I think we would do, if we imagine these as lighting trusses or lighting towers, we probably wouldn't link our towers horizontally. We'd probably go up and down. So we've got a cable that feeds each one. So let's map them in that same way. So let's go back to our table. So we are going to be interested in moving down through our vertical space first. So 1, 2, 3, 4, 5. So 2, 3, 4. So there is our 5 lighting fixtures on our first one. Starting counting at 0, 0, 1, 2, 3, 4. So in our horizontal space, we've not moved away from our first row or our first column. So all of these can be set to 0. Because we're just applying 3 channels per fixture, I'm not sure why that keeps drifting out of the way. Because we're just applying 3 channels per fixture, everything is going to stay within universe 1, so that's fairly easy to fill out. And then as we move up through the fixtures, we're just going to add 3 addresses. So the first pixel is going to have 3 addresses for its red, green, and blue information. And then we're going to move down and we're going to give 3 addresses for the red, green, and blue information of the second light in the column. So this is, we can just do this with a quick formula. This is going to be that channel plus 3 channels, and that gives us, and that way, rather than having to do some sort of mental arithmetic, it should just copy that down. So as long as I've just got that second one highlighted, there we go. So we've mapped our first column of lights, and we can just there we go. Now we can move through. So we've got 8 columns, so we can copy these 2, 3, 4, 5, 6, 7, 8. And then these are going to increase by one every time we go through this cycle of 5. So this is going to be 1, 2, and so on. So we can copy those down. And by the time we get to the bottom of this table, we should be on number 7. We know that because we are 8 columns wide and we start counting at 0. So by the time we get to 7, we've got 8 columns. So that's great. I happen to know that this many pixels will stay all within one universe, so that can be copied down. Obviously, if you get to 512, then you have to move over to a new universe. And then our channel numbers, if we just sequentially map these 3 channels at a time, we can continue to copy this formula down. So there we go. And that would be a valid table for this array of lights. We can move this into disguise. So the last thing to do is to save this in a format that's going to work within the disguise file structure. So we need to save this as a CSV file. I'm going to go save as, let's find my DMX table screen folder on my desktop. Not an XLS or XLSX as it is these days. We need to come down to CSV MS-DOS. And then, so just give that a name. So just save that. And now we're good to move on to disguise for step 3 to pull this all together. So I'm going to just create a new project. Go right click the project, open the folder, go into objects. Now we copy in the bits that we've just created. So if I go Control N on my keyboard, I can grab a new Explorer window, leave my objects folder on my right, go to my desktop, and that's where my DMX table screen was. We can delete the material file because we don't need that. As always, the model files go into the mesh folder. So I'm just going to copy that there. We don't, as default, have a space to put our table files. So you just create one by Control-Shift-N on the keyboard to create a new folder. And then I'm going to create, it needs to be called table. And in order for D3 to see that correctly, so copy that in. And we should now be ready to launch Disguise and get this all set up.
A few moments later.
So we're in our disguise project. Let's just do a little bit of housekeeping to a new project. We don't really need our projector or our surface, so let's take those out. In order for any DMX data to be able to leave your system, you need to add a DMX device to your device menu. So there's a default one there already created for you. It's going to be mad at the moment, and that's because if we right-click on the device, you'll see that there's no remote IP, so Disguise doesn't know where to send the data that it's collecting for your light. So I actually don't have a lighting desk or a lighting node on my home network, so there isn't actually a place for me to send this to, but I can just set that to a loopback address, and that'll make that module happy. If we wanted to change from ArtNet to, say, streaming ACN or any of these other protocols, we could do that by clicking on the number at the top. And that's probably everything we need to do in our devices menu. So we can close that, go back to our stage and add a DMX screen. Just going to call this lighting array. So this is the default. Let's just move this up a little bit. So this is the default. This default DMX screen that Disguise creates. So it's a square screen, and it's numbered in rows, sort of top to bottom. You might recognize these numbers because that's the same way that we numbered our table. So if we load our model and then set our resolution correctly, so it's 5 pixels wide. That's a lie. It's 8 pixels wide and 5 pixels tall. So assuming that your lights were jumping in sort of by 3 fixtures at a time, this actually could be enough to get you the lighting data that you need out of Disguise. The reality is, though, But unless these were a set of LED park hands or sort of, a very, very simple lighting fixtures, often we wouldn't be jumping just 3 addresses at a time. So there would be some control channels in between. It might be pan, tilt, gobo, control, or, shutter. So that's where the standard DMX screen kind of falls down a bit in disguise. And this is where building your own table to control the addressing can be really quite powerful. So this is our standard DMX screen. We can open a bit more and go down to addressing. Turn the status to active to allow you to actually output. By default, Disguise doesn't actually output any data, so you have to activate your DMX screens in order for them to produce something. Here is the table, so it's going to look in that folder that we created inside the file structure, and you'll notice because we labeled our table in the same way, nothing has changed. So let's see this through to the end, and then we can show you the power of using a table to control that by modifying the table to allow us space for some control channels. So first of all, I'm just going to create a radar module. So if we go back into our DMX device, right click that and look in our DMX monitor, we can see we're now from a graphic, just like a radar module, we're now producing the lighting channels that we need to control each one of these lights. And if we created a video module, we could do the thing with any piece of media. So could sort of add George to that, and that's the correct values in order to make your light sort of display. So obviously much more powerful with dynamic sort of moving content because we have enough resolution there to really see what's going on. So that's why I think a radar or something generative and moving can be a good way to test your lights. As you can see, all the data's there. Essentially being output. Obviously I don't have a collection of lights to connect to, but this is all working the way that it should, and we can see that here. So as I mentioned, we've not really made any specific use of our table yet because we created the same set of fixture addresses as the default DMX screen is in Disguise. So let's just sort of pause that and pop back into Excel. So let's think that the control channels in between each one of these fixtures is now going to be, let's say 12 channels or something like that. So let's renumber, let's do it correctly. So we've created a formula, which is the second fixture is now the first one plus 12 channels. And then we can copy that down for the rest of our fixtures below. So we've just got pretty much a full universe of lighting data there. So we're going to we're going to save this out again. Give it a version number. And then there's our table folder. Going to copy that in. So now we're back in Disguise. You can see that our new channel data has been passed to each one of these lights, and that's a really powerful way of being able to have a custom lighting address for each one of the fixtures in your array. So you're just not able to do that with the standard Disguise DMX screen. That's why being able to use a table to set up your addressing data is an incredibly powerful tool. And there you have it. Disguise is now controlling our lighting products by pulling the brightness and color data from the video file, or in the example that we've set up, a radar module. Thank you for watching and supporting the channel. Please leave a comment if you have any questions about this video or anything else that you'd like to see on this channel in the future. From everybody here at Hive School, see you next time.